Good day, class. In this lesson, we will learn to multiply polynomials. Now notice, we did adding and subtracting polynomials, but multiplying and dividing are actually isolated events. So we'll focus only this time on multiplying polynomials. One of the most prevalent operations that you'll be asked to perform is to distribute. This is an act of multiplying polynomials because we have that monomial of 2x and we're being asked to multiply it, indicated by the parentheses, by the binomial 5x plus 3. So note, anytime you have that set of parentheses and something sitting right outside of it being multiplied, then it's time to distribute. So I'm going to multiply 2x times 5x. Based on what we know about multiplying and the laws of exponents, those x's actually become x squared when we're multiplying. We have x times x. So the 2 times 5 yields 10, and the x times x yields 10x. So what we actually have when we multiply 2x times 5x is 10x squared. You're also responsible for multiplying that 2x times the 3. We have to distribute throughout the parentheses just as we did in the past. So notice 2x multiplied by 3 becomes 6x. And now you just have your terms sitting there. We have a positive 10x squared and a positive 6x. So our simplified version of 2x times the quantity of 5x plus 3 becomes 10x squared plus 6x. In this example, we're also asked to distribute. In fact, we're going to deal with the same example, but for that negative sitting on the outside. And here I just want to emphasize how important it is to respect the negative value, or anytime we are multiplying with negatives. So I'm going to multiply that 2x times 5x, or that negative 2x times that 5x. I'll end up with a negative 10x squared. And remember that negative distributes to the 3 also. So a negative 2x times a positive 3 yields a negative 6x. In this example, we're asked to multiply two binomials by each other. So I see a binomial on the left, 2x plus 2. I know that's a binomial because it's a polynomial with two terms, like the bicycle. And I see also on the right, 5x plus 3. It is also a binomial. It's a polynomial with two terms. Whenever I see this, I'm going to use the FOIL method in order to get those multiplied. And essentially, I'm just going to continue repeatedly use the distributive property until I've distributed both the 2x and the 2 throughout that second set of parentheses. In other words, I'm going to multiply my first terms, my 2x and my 5x. Those are the first terms of both binomials. That yields 10x squared. I'm going to multiply my outer terms, 2x times 3. That yields 6x. I'm going to multiply my inner terms, 2 times 5x, that yields 10x, and I'm going to multiply my last terms, the 2 times the 3. Once I've done that, I should note that I have terms in the center that actually happen to be like terms. So I'm not actually finished until I simplify this all the way. So I'm going to go ahead and combine that 6x and that 10x and tell that I have 16 of those kinds. So what I really have in the most simplified version of these binomials multiplied by each other are 10x squared plus 16x plus 6. In this example, and our final example, I'm going to demonstrate how applied multiplying of binomials can be applied. So in this case, we're asked to find the area of this rectangle. Now, normally we're just used to numbers sitting there and not necessarily polynomials. So that's okay. We just know that the formula for the area of a rectangle is area is equal to base times height. So we're just going to multiply the base and the height. And recognize that in this case, we need to distribute that x throughout our second set of parentheses. So I'll do that. X times 3x squared is actually 3x to the third power, or 3x cubed. And x times negative 7 is 7x. At that point, you're finished and there's nothing more to do because x cubed and x cannot add or subtract.